Today, we are going to be working on congruence. Now, congruence is proving that this triangle right here, let's call this triangle ASD, or I guess it would be DAS, sorry, is congruent or equal, indicated by this sign, to triangle X, Y, Z. So, a lot of people struggled with this when I was younger, but I really like the subject, so I figured I'd come and teach it. We're going to be writing proofs. You're going to be asked for proofs for DAS is congruent to XYZ, if I remember correctly, in your tests. And there's a couple different ways that we show that, because obviously, you know, they can look similar and whatnot, but we need to show mathematically that they're the same. So you're going to be seeing these letters a lot. SAS, SSS, ASA, AAS, RHS. Now the thing with these is they are all ways of showing congruence. So SAS is away, SSS is away, ASA is away, AAS is away, and RHS is away. And at the end, you need to show which one you're using, and you need to show how it works in your proof. So for instance, if I wanted to prove that this blue triangle is equal to this red triangle here, what would I do? I would go, well, you have one side that's the same, indicated by this little line here. Then you have one angle that's the same, and then you have one other side that's the same. And these sides are the same as each other in an internally consistent order. So it goes side, angle, side. Side, one side, angle, side. See? And so if a triangle has the same side, then the same angle, then the same side, in that order, it's congruent. Or if the triangle has the same side, then another side that's the same, then another side that's the same, so that's three sides, that's also two congruent triangles. And then if a triangle has an angle, so these two are the same, then a side, so this side is the same as this one, and then another angle, and this angle is the same as that angle, that side is the same as that side, and then this angle is the same as that angle. In that order, we have a congruent triangle. Lastly, we have AAS and RHS. So AAS is angle, angle, side. So if you have a triangle, or two triangles rather, with two angles that are the same, then another pair of angles that are the same. Sorry, hang on. Let me draw this a little better here. That was incorrect. That was incorrectly drawn. So, we're going to have angle, angle, side. 1 second. Show that this is another angle. Okay, there we go. And then we're going to have angle, angle, side. So if you have that, you can prove that these two triangles are the same. And then here, this is a special case when you have a right triangle. So you need to prove that you have a right triangle. So you need to prove that you have a 90-degree angle inside your triangle somewhere. And then this side, one of the sides, and the hypotenuse, which is the one opposite to the 90-degree angle, need to be the same so that you have congruence. And then the way we would write congruence is, let's say we have these two triangles here, DAS and XYZ. And we say DAS and XYZ, we're going to try to prove that they're equal through, I don't know. Let's try to prove that they're equal through side, angle, side. Just for an example, and I'm going to make them very obvious because, you know, for ease of access. For ease of this example. So, one side, one angle, one side, And then one side, one angle, one side. So we're going to say, and I'll write it out really long. This is a full proof, by the way. So, whatever. So look. A, measurement of angle A, is equal to measurement of angle Y. Sorry. I mean, you could start like that. It doesn't really matter the order you prove it in, but I'll prove it in a consistent order with the SAS, just so it makes a little more sense, I guess. So we're going to go side AS, denoted by a line AS, is congruent to line YZ. And then we're going to say, so usually you're going to want to have a reason, right? But since it's given here, we're just going to put given. There's a lot of different reasons you can have, and it depends on whatever example you're doing. But anyways, for here, it's given. And then we're going to say measurement of angle A is congruent to measurement of angle Y. And then we're going to say side DA is congruent to side XY. We're going to write given for both of these because it is. And it's given because when you have a little line indicating an angle like that and then another little line indicating an angle like that, if it's not two lines here and one line here, it means they're the same angle. And then for the sides, when you have these little things crossing the sides, see this line here and this line here? So if there's like one line on one side and then one line on the other side for two different triangles, one line intersecting, it means that whatever side has X number of lines intersecting it, so say YZ has one line intersecting it, AS has another line intersecting it, that means that these two sides are the same. And then here, DA and XY, they both have two lines intersecting them, so that means that DA is the same as XY. Anyways, so here you give all the reasons, so side, angle, side, and then you say hence, triangle, hang on. DAS is congruent to triangle XYZ. And then for the reason, you're going to write side, angle, side. Or, you know, whichever one you used. But here, it's side, angle, side. It's pretty obvious. That is how you prove triangle congruence. This is one example using side, angle, side. Remember, you can use side, angle, side, three sides, angle, sides, angle, 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 side. Or you can prove that in a right triangle, the hypotenuse and a side are equal, and you need to show that it's a right triangle as well. That's it, pretty much. Thank you for listening. This is how you write a proof. Also, remember this. This is important. This is on every test in 9th grade, I think. Like after second semester, it's pretty relevant. Or I mean, it's definitely on your final for semester 1, so keep it in mind. And it's also kind of important just in general. It's a geometric proof that you should remember. One more thing before I go. What you always want to remember when you have one triangle. Triangle 1. You have triangle 2 over here. You cannot, absolutely, do not ever, under any circumstances, use side-side angle. side angle cannot show cannot, absolutely never ever show congruence. That does not work. If you show that this side and this angle are equal to this side and this angle, these two triangles are not necessarily congruent. Keep that in mind, please. The other ones, the ones I showed before, all great, all good. This, no, absolutely not. People do this every year. They give a whole proof for side angle, and then it's wrong. Do not do this. Finally, here are all the congruence rules you can use and the one that you can't.